Hello, welcome back. So in the previous part, we have discussed about the general requirements of the batten system. Now in this part, we will start the discussing about the design requirements. So design requirements is given in this clause. So we can refer to this clause of IS code for all the references. Now, to be specific, if we discuss about the forces, how the force is coming in the batten system. So as I discussed earlier also, if these are the two main component and if they are supporting this load, then what happens is these two components try to get away. Now to stop that, what we are doing is either we provide lacing system or we provide the batten system. So this batten, now as we are discussing about the batten system, so this batten is actually trying to hold these two members. Now while holding these two members, this batten experience some kind of force. So that force we are supposed to find out. So as per IS code, how much that force will be resisted by the battens, we will find out. How much force will be experienced by this batten, we will find out that. So it says battens shall be designed to carry bending moment and longitudinal shear force arising from transverse shear force. So as now you can see that in the lacing system also, lacing experience the force which is about 2.5% of the axial load, total axial load carried by the built-up column. Uh, the same point is there here also, like the batten system will also experience the same load, which is 2.5% of the total axial load, and this force is actually transverse shear force. So we will see that. So there in this case you can see this is the column and this is the batten system, and these batten systems are actually experiencing this force, which is the transverse shear force. Now how much this transverse shear force is? This is actually 2.5% of the total axial load which will be carried by this whole built up section. So the same formula we have used in the previous lecture, now we are using the same here also. So this much force this particular batten, each and every batten will experience. Now in this case, P is the axial force on the compression member. Now coming to the next point. Now there is one special thing about the batten system is that the transverse shear, it is this transverse shear which is being applied on this batten, it will actually induce two kind of effect. First effect will be in the form of longitudinal shear, and the second effect will be in the form of moment. So this transverse shear will actually induce two type of effect. One is this longitudinal shear, which I am representing by VL, and at the same time the same force will also induce a moment, and this moment will be M. So ultimately, because of this force, this batten will experience these two forces. One is VL, which is a longitudinal shear force, and M. M is the moment in the batten. Now, to find out the value of VL and M, IS code has provided the formula to calculate that. So as per IS code, close this one, the value of longitudinal shear force can be calculated by using this formula Vc upon Ns, and the value of moment can also be calculated by using this formula. So both of these formulas are provided in the IS code, so you can refer to that. Now in the formula, what is V? V is the transverse shear force, this one. So we have already discussed about V in the previous slide, which is 2.5% of the axial load. Now coming to the C, C is the spacing. There you can see this is the C value, which is so center to center distance between the consecutive batten system, battens. So there, this is the C, C is the spacing. Now coming to the N, N is the number of parallel planes. Well, in our, in this case, you can see there are two channel sections which are placed face to face, and to join them, there are two planes of battens. One plane is this one, and the second plane is this one. So in such scenario, we are providing two planes to, for example, if we are designing some, built up column with a four angle section like this. Okay, and in that case, if we have to connect these four angles, what we have to do is we have to provide batten plate on this side, and on this side, and on this side, and on this side. So in this scenario, you can see there are actually four parallel planes. 1, 2, 3, 4. So in such scenario, the value of n will be 4. But in this scenario, we are providing only on the two faces. So in that case, n value will be 2. Similarly, if we provide channel sections like that also, in that case also, we will provide batten like this. So in that case also, n value will be 2. Or if we join two I section like this. So in joining two I section also, we will provide batten plates like this. So in that case also, n value will be 2. But in such scenario, it will be 4. So this is how we find out all the values. Now the only remaining the thing remains is the value of s. Now s value is actually the centroidal distance between the rivet group. Say for example, this batten is connected with the main component using the bolted connection. So there are a group of bolt or rivets. There may be rivets also, but as in this code, we are not using rivets. So there may be bolt group. So CG of bolt group will pass through this. So on the same time, this also. So in that scenario also, you can see we can find out the S value, which is actually a distance between the centroid of the bolt groups. So the same I have discussed, I have explained here. Coming to the next point, the size of batten. Well, how do we find out the size of batten? What should be the depth of batten? What should be the thickness of batten? And what should be, what would be the length of batten? So how do we find out that? Well, this is also given, some references are also given in the IS code, and the same reference I'm using here in this PPT. So you can refer to that IS code disclose. So first, if we talk about the thickness, how do we find out the thickness? So IS code has recommended some points. They have, it has suggested some points, and according to that, we will estimate the batten thickness. Well, as per IS code, it says the thickness of the batten plate or the tie plate should not be less than 1/50th of the distance between the innermost connecting rivet or bolt or weld. Well, we can write this like this. The minimum thickness of the batten should be more than the value of AI by 50. Now, what is AI? AI is the distance between the innermost connecting rivet. Now, I will show you that through the diagram. So in this case, you can see there are two rows of the bolt, and the innermost line of the bolt, in this case also, the innermost will be the AI value. Now, for example, by chance, if we have only one line of the bolt, like if we have only the one line of the bolt, then how do we find out that AI value? Well, in that case, the only line distance between this will be AI, and at the same time it will be equivalent to the capital S, which I had just discussed. So in this, to differentiate between AI and S, I have provided two rows of the bold to show you how S and AI is different. But in some cases, they may be same. If by chance, if we are having only the single line of the bold, in that case, AI and S will be same. Now, there is one thing that you need to consider, that this capital S is the distance between the centroid of the group of bolt, and below this I have provided a small s. Well, this small s is actually the spacing of these two members. So please don't confuse with this. Small s is the spacing between the two members. Capital S is the distance of the centroid of the rivet or bolt group. Similarly, if by chance, if there are weld plates, say for example, if there are weld plates, like this is the batten, and there may be welding like this, and here also. So the inner part, the innermost point of the weld from this side and innermost part from this side, this will decide the value of AI. Weld may be up to this point or maybe somewhere here, but we have to simply need to see which one is the innermost. So by chance, if we are providing welding up to this point, so in that case, up to this point, up to the edge, in that case, AI will become equals to the small s. Sometimes we may not provide welding up to the edge. We may provide welding up to this point only, and here also up to this point only. So in that case, AI value will become this one. So we need to see the condition. We need to calculate the AI value accordingly. So in that case, it will be the AI value. Now, so I have already provided here distance between the innermost connecting line of the rivet and bolt group. Now coming to the next point. So in the size, now we know that how do we find out the thickness, this thickness value, which is AI by 50. Now coming to the next dimension, which is the depth of the batten. Well, there are end battens and intermediate battens. So the depth for end battens and intermediate battens will be different as suggested by the IS code. Now, first of all, we need to understand that there will be two types of depth. One will be the effective depth and the other one will be the overall depth. Well, effective depth, there you can see this one is the effective depth, which is measured from the center of the extreme hole of the bolt. So center to center of this distance to this distance, this will be the effective depth. Now this effective depth as per IS code shall be taken as the distance between the centroid of the main member. Now in the cross section here you can see these are the channel section and their individual CG will be here. Their individual CG will be here. So the distance between these two CG will be A. So it says that the effective depth of batten shall be taken as the distance between the centroids of the main member. So which means this D will be equivalent to A. But at the same time, IS code also has suggested that this calculated value of D should always be greater than B, which means if we are taking D as equivalent to A, but at the same time, they should be more than 2 times of the width of the member. Sorry, this is not a batten. This is actually to be, sorry, this is correct, battens. Now, what is B? B is actually the width of flange of the section. So in that case, if D is equals to A, but at the same time it should be more than the 2 times of the width of flange of the section. So that funda we need to satisfy. Now this is the condition that we will check for all the battens and the uh, intermediate battens. Now, as I said that D will be equals to A. This condition will be applicable for the AND battens. If there are AND battens, then D will be equivalent to A. And for intermediate battens, D will be equals to 3/4 of A. But also at the same time, this value should also be more than 2 times of B. And that is what it is saying in the third point. So I'm again repeating it. It says the effective depth of batten should be more than 3/4 of A. So A is this one. And this condition will be applicable for intermediate battens. Well, at the same time, D should be or equals to A in case of AND battens. And for both case, D should be more than 2 times of B, and B is the width of flange. So this is again recommended by the IS code in this clause. So you can read that. So this I have mentioned. D is the effective depth, A is the centroidal distance of the member, and B is the width of member in the plane of the batten. Okay. Now, this D calculation for different cases may be, some of you may get confused for different cases. How do we find out this small d value? Well, I will show you some of the cases which you may encounter. So first case is this one. In this case, the channel sections are placed back to back. So this is the case of back to back. So in that case, as I said, as per IS code, effective depth will be equals to, it will be equal to this distance, the distance between the centroidal axis of the two members. So this is A in this case, and A will be equals to D will be equals to S plus 2 into CYY. Well, this CYY is the value. There you can see this is the CYY value, this distance. So Y dash is the individual Y axis of this channel section, and this is the CYY. So ultimately A is summation of S plus this CYY plus this CYY. So CYY value we can find out from the steel table. So whichever section we have, it will be having CYY value, which we can find out from the steel table. So that is case one, when the channel sections are placed back to back. Now in the second case, if the channels are placed face to face, so this is the second case in which the channel may be placed face to face. So in that case, again, we have to find out this distance. But how do we find out that? In that case, D will be equals to S plus 2G. In this case, you can see CYY is excluded from this point, and this distance is G, which is the gauge length. We call it gauge length, and we represent this by G. So in this case, D will be equals to S plus 2 into G. Now, in the third case, if we are using two I sections as a built-up column, in that case, how do we find out the D value for the batten system? So in that case, the D value will be again the distance between their CG. So this time the D value will be equals to S plus D. So this is S, half of the flange and half of the flange from this side. So again, you can see we are actually taking this distance. So sometimes you may get confused. So that is why I have taken different cases so that you understand how do we find out this effective depth. And this effective depth is actually for the end battens. So once you find out this effective depth for the end battens, you can find out for the intermediate batten also, because that will be 3/4 of D. So if I say that effective depth of end batten as DE, so I will say I mean effective depth of intermediate batten, if I represent that as DI. So in that case, DI will be equals to 3/4 of DE. And DE is the effective depth of end batten and DI is the effective depth of intermediate batten. So all these formula that I'm showing you, it is for the end battens actually. So once you calculate it, you can find out for intermediate as well. So that was it in this part. So we will continue our this lecture in the next part. Thank you.